Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on brown cows and an introduction to binomial distribution. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of video. In this series of PowerPoints, we have introduced the binomial distribution and shown how the formula for the binomial distribution works. And this is part 4 of this video set. Now we're ready to do an example on binomials. Assume that 15% of all people are left-handed. There are 14 students in a class, and find the probability that, and we have parts A, B, and C. Since there are multiple parts, we will need to keep up with our answers as we go. What characteristics make this a binomial? First, we need to determine if it is a binomial distribution. Is there a fixed number of trials? Each student is a trial, and there are 14 students in a class, so 14 trials. Each trial is independent. One student being left-handed doesn't affect the other. In other words, each student had his or her own probability of being left-handed. It didn't depend on which hand the other students used. Each trial has 2 outcomes. From the problem, the success is being left-handed and the failure is not left-handed. And the probabilities remain constant for each trial. The probability of each student being left-handed is the same. So we do have a binomial distribution. Success is left-handed. Each student is a trial, so there are n equals 14 for our number of trials. The probability of success, remembering that the success is left-handed, so the probability of being left-handed is 15% or 0.15. Q is the probability of failure, and remember to find Q, that is 1 minus P. And that is the probability of not left-handed. If 15% of the students are left-handed, 100% minus 15% gives us 85%, or 1 minus 0.15 gives us 0.85, our probability of failure. And lastly, the number of successes, X, can be 0 through 14. And notice that we do not need to write all of those numbers, just indicate that it's going through 0 through 14. These are required steps if you are in Mrs. Borlaug's class. And it's a great way to organize yourself and get ready to use the formula. I encourage every student to follow these steps. In the A part, we were asked to find the probability that exactly 3 students are left-handed. In the B part, we'll find at most 3 students are left-handed, and the C part, at least 3 students are left-handed. Let's start with the A. Exactly 3. So we're only looking for the 3. So I will organize and keep my information in the table as is indicated on the screen. At most 3, and if you've not watched the video that I have on the phrases at most and at least, that may be necessary to understand this video. But at most 3 would be 3 or less, and I've circled 3 or less, which would be the numbers 0, 1, 2, and 3. And at least 3 would be 3 or more, which would be the numbers 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. In this case, since there are so many numbers for the at least 3, it would be easier to find the probability using the complement and then use the complement of that to find the answer. In other words, find the probability of x equaling 0, 1, and 2, find that total, which is the complement of what we have circled here in red, and take 1 minus the total that we have to find our answer. And we'll get back to that when we get to part C. Let's go back to the A part, exactly 3 left-handed students. Here to the left, we have our variables listed down again. N equals 14, P equals 0.15, Q equals 0.85, and our X's are 0 through 14. And for the A part, we want exactly 3. Since we have a total of 14 and we're looking for 3, that would be 14, choose 3, or 14 combination 3. Our probability of success is 0.15. We want 3 successes, so that would be 0.15 to the third power, times, well, if 3 of them are left-handed, out of the 14, that would be 14 minus 3, or 11 of the students to be right-handed, and the probability of being not left-handed, not necessarily right-handed, but not left-handed, would be 0.85. So we have 14C3 times 0.15 to the third times 0.85 to the 11th. And when we calculate that, that gives us 0.2056. Ms. Borlaug rounds these to 4 decimal places. Please follow your teacher's rounding rules. And the answer is there is a 0.2056 probability of getting exactly 3 left-handed students. Let's look. Well, we're not going to look. We're going to stop right here, and I'm going to have to make an A and a B part to get through this example. Because I don't want to run over time or make the videos extremely long. So please watch the next video to do the at most and the at least parts of this example.